Neighbors run here at the warehouse where a lot of the restoration of the ship is being conducted. We've got projects all over the place here, and they're being disassembled, cleaned, and put back together in as much function as allowable. A lot of the painting, priming, rust removal, baddies have been removed from these items, and they'll go back on the ship in a primo condition, very nice condition. One that'll hopefully remain as long as the ship is out of the shipyard, which may be 20, 30 years, something like that. Well, let me show you what I'm doing. Let me give you some idea of what's going on here. Here I'm looking right at it, actually. I'm looking at a bunch of 20 millimeter gun parts. These are gun magazines, 20 millimeter gun magazines that have been blasted in the cabinet here and are getting prepped for painting. Typical magazine, you can see the shininess. This is the actual bare metal. So all the old paint has been removed with high pressure sand in a blast cabinet, and then a top coat will go on top of it. It's a product called Cerakote, and it's used by the premier gunsmiths of the world. You can check it out, do a Google search on it, and it's preferred over the traditional or usual finish of a gun barrel, bluing, for example, or parkerizing, for example. The surface doesn't rust. So a lot of people have their guns and their barrels and whatever, their collectible items Cerakoted. Sometimes, for whatever reason it may be, maybe to hide it, make it more camouflaged. For example, you can Cerakote a Colt 45 pistol in white instead of the traditional black and brown. If you were in a snowy area, you would see that clearly. But if you want to blend into the rest of the environment, you would have it, so you could have a Cerakoted white, and maybe a little white camouflage, that kind of thing. And same thing with a gun barrel or anything like that. In this case will be, I'll show you an example of some of the Cerakoted barrels and 20 millimeter guns. And also I believe one of the magazines have been Cerakoted already as well. It's an expensive process. Takes a lot of money. It costs more than bluing, actually. But the results are much better. Again, you can leave it outside in the weather, in the rain, for years, and you won't have to worry about it. The paint is ceramic and very hard, and you have the ability, or if you have the inclination, you can have your automobile ceramic painted. Very expensive, much better than the factory finish of a typical automobile. So anyway, check it out, Cerakote. I'm not a client or seller or anything like that. I'm sponsored by Cerakote products, but you definitely have Nate Bergeron's seal of approval. So this is the Mark 27 gun director. There are two of them on the ship. One's on the port side, one's on the starboard side. And their function is to give an alignment or direction for the torpedo to be lined up before it's launched and targeted to usually another ship. Anyway, this is the internals. This is the face removed. They're typically, with all the dials and everything on the face, it would look something like this. And this is the better torpedo director, one that was on the starboard side. And I'm leaving that for last because it's the one that's in the best shape. This is the worst shape. This was in the worst shape. So it needs to be completely cleaned up, disassembled, all the corrosion removed. You can see this is essentially, this dial face is essentially what the rest of this looked like. You can see corrosion through the dial, this heavy amount of corrosion here. You can see the original background, this black, slightly shiny, dull black for the face of the instrument, all across here. Well, I mentioned illumination, illuminating the instruments. It's all done from behind. So the faces of the dials are you can't really see them. You have to look through them. So if you held this up, this has got the painting all the way through it. If you held this up to the light, you could read the dials. They're cut into each dial face. So, and being aluminum, very delicate, and you've got to watch out for corrosion. This is some of the illumination device that goes into it. All these heads hold low voltage, 12 voltage, 12 volts, something like that, light heads, and they deliver light from the backside of the instruments.
Through this thing?
This is one of them. This particular head, light is reflected through this, kind of like a prism in a way, or a cable light communication. Light is directed through this cable, well, this rod of plastic, and it illuminates the backside here. There was a telescope that's mounted on top of each one, and individual cranking in all the information, torpedo, course, target. He's basically lining up what he's looking through in the telescope with everything else here. So basically he's lining up the sight, lining up, say, the crosshairs on a rifle, for example. Similar situation, only this is a much more complex telescope. Let's put it this way. Maybe the correct word is gun sight.
Okay.
And this is the gun sight. And you know, looking through the eyepiece all the way through, and this would be the face. And probably more so than anything else, Molly, this is similar to the telescopic device that's in each 5-inch gun.
Oh, okay.
So there's one for the pointer and one for the trainer.
This is like a miniature version?
Yeah, exactly. Smaller version. And you remember the little access panels opening on the 5-inch guns, and that face is about this big. Well, this face is about that big. So it's a little portable booger. But anyway, same thing. And
That's cool.
the guy's standing up here versus in the 5-inch gun, he's sitting in a little bicycle seat, cranking away, cranking up the alignment. Obviously, you know, we mentioned pointer and trainer. Well, in this case, torpedo is only training. You know, it's not, there's no vertical in the target of where the torpedo's going. It's right there, yeah, on the water line, because torpedoes, you know, from 0 to what, 50 feet. And the depth is set before it's launched. This is brass, cast brass actually, which is difficult to do. So you make a piece, and then you pour hot molten brass into it, and then you take it out of the cast. So it's one of those, hey, just have one on this. You have to make another mold, and then pour more brass, make another one, etc. And you can see, identify a brass casting, or any kind of casting really, when you look at the metal itself. And you can see usually where there's a break line between the two.
Like you can see the mold.
Yeah, you can see the mold material. And this is usually done with sand. It's a casting sand. So each piece is put in with a plug into sand, removed, and then the molten metal, in this case brass, is poured in. It's allowed to cool, and then you remove the molded sand. It's really neat. It works with jewelry, works with small things, small pieces of brass, or it works with big chunks of brass, a lot bigger than this. It just depends, I guess, on how big, how much brass you have, and what kind of foundry you have to cast that. On this particular one, it's chemical, using the chemical etch, put on the any kind of chemical paint remover, and paint it on, and then allow it to sit, and after about 6 hours later, blast it off with a high pressure water blast or a slurry blast, sand mixed with water, and it takes it right off. Or you could do it with a scraper, same thing, take forever, or a small wire brush, you can do that too. But the chemical etch works a lot better in the small little spaces, otherwise you'd be there forever. You wouldn't want to put something like this in a blast cabinet because you're dealing with glass, etc. You wouldn't want any of that in there where you etch away the nice shiny instrument, watch quality product in the blast cabinet. These are all pieces of the Mark 27 torpedo director. As I finish them, as I have them blasted, I'll put etching primer on the top. This is just bare metal. That's what it looks like coming right out of the blast cabinet. It looks like almost white, but that's bare aluminum. It'll get a slight coloration after it's dipped in acetone and anodized, and then it'll get the top coat etching primer. This is an example of some of the Cerakote on a couple of gun barrels, 20 millimeter gun barrels. You can see it looks like the original, like a bluing, only there's no oil on it. You don't need to oil this. It's a finished coating. You could put oil on the top of it to give it that battle-ready use or something that you leave out. But this is the product that'll remain. You could leave it out in the sun for a decade. Paint doesn't chip, doesn't burn, doesn't rust. So it's a proven product. Behind me are some pieces to the dials, the dial face on the Mark 27. They're being wet sanded down very lightly, prepped, all the corrosion removed, and then getting ready for the acid bath to anodize it and repaint. Putting a Cerakote top coat on it. Probably a slight gloss black. That was what the original was, and the original is going to be what goes on top of it. The anodize will protect it forever. It's not going to corrode. That's an aviation standard acid etching, but just the anodize will last long enough. With the top coat, of course, to eliminate the reflectivity, you want this dark so it doesn't shine off or act as, say, a mirror. You want to keep everything concealed. We talked about this, the openings through all the dials, the way it's cut out. It's not something put on top of it like a typical dial. These dials are cut all the way through. And this is all 45 original. I can't get an idea from anybody how this was done back in the 40s, but these days you would use a laser and just cut small dimensions like that through a material easily, especially if you had a lot. So it may be an acid type paint removal system to get the cast, these original dials. Same thing here on the back plate. You can see, you hold it up against the light, you can see the holes cut through it. Talked about. So it's kind of unusual in the world of instruments. And I've worked on my share of instruments on airplanes. They typically everything is done on the face of it. The illumination is on the face of it. On these, the illumination is on the back side of it. It kind of like goes through. And it's very unique on this particular instrument, if you look at it as an instrument. All right, this is one of the Sperry 36-inch searchlights. There are two on the ship. one on the port, one on the starboard. This was the one that was on the starboard side. It was the better one. This was functional about 35 years ago. Carbon arc, super bright, super hot, super everything, just a super lighting device. They really don't make these anymore, but I'm opening it up. And you can see the internals here. At the moment, the iris is partially open. You can control the amount of light with it, but the iris control is basically like the human eye. You can open and close and allow more light, 100% light, or you can close it and direct it to a nice pencil light. So instead of taking light in like in a human eye, you're pushing light out. So you're reversing the human condition here. We'll open it up. Just a simple explanation. Carbon arc rod. So you have a carbon arc, and you have the anode and cathode kind of thing. When you energize it through DC voltage, you have an arc that goes from one end to the other, called the anode and the cathode. In this case, the carbon arc rod is the part that gets burned, or where you see the light, the plasma. Call it plasma light. Anyway, it burns right here, and it's rotated slowly around so the burn is nice and even. Not like that, but a little bit smoother. Kind of like a cigar. If you ever smoked a cigar, you would put it under a flame and you'd want to rotate it. You wouldn't want to just put the flame underneath the cigar because it would burn. You'd burn it offset. You want it nice and rounded, and then you'd have a heated cigar if you want to look at it like that. Anyway, carbon arc rod. This is what burns, and this is what produces the light. Being all aluminum, you can easily feel the heat when it's in operation. And I've actually run this one for several hours. You can feel the heat coming off the aluminum just by touching it. It gets hot quickly, but there's a device on the very top that helps cool it, and it's a cooling fan. Makes a lot of noise, sucks a lot of the heat out, and also sucks a lot of the smoke that's generated out. And you'll get a lot of smoke. If you've ever been to a performance outside and they used carbon arcs years ago, maybe in the 70s, in the 80s, you would see the smoke coming off of where they would run the light rod through the sky. Kind of like a Batman show. They'd have the carbon arc rods on them,
Wow, the bat signal!
This is how the bat signal worked, you put the big bat emblem right here, and you throw it in the sky. So you could do that. From the bat cave, It is, seriously.
This is your bat cave.
This is my bat cave. It's my bat cave.
Kid cave.
Yeah. Kid cave.
You mean the bat cave?
Bat cave, kid cave. So this is pretty much an example of what 37-inch Searchlight looks like. The motors, slave motors, the gearing, capacitors, drive motors, servo motors, pointing and training. The quill, you can see part of that's the quill cover down here. All that came, and the quill that you may have seen by the Mark 27s came off of this one. So the quill, the way it's designed, the quill allows all the contacts to remain in place as the Searchlight is rotated around. Clockwise, I can do a 360 and still be connected without, say, twisting a wire. So we had all these wires going to the bottom side or through the Searchlight or any Searchlight, but you're able to spin it around left and right. quill allows contact, all the electrical connections to remain as it spins. You spin it left or right, or clockwise or counterclockwise. This is the quill, the core of the quill. This entire piece rotates, so this remains attached to the bottom without rotation. And on the top of the quill is the drive mechanism. So it's kind of like an axle. And this part is connected to the rest of the Searchlight, to the actual core or base of the Searchlight. So when the Searchlight turns around, it drives the inner core of this quill. The outside remains stationary, but the inner core spins either left or right or counterclockwise, clockwise. And these are the fingers, the electrical connection that remains in place as it goes around. So any positioning at all, when it's trained, when the Searchlight is trained, either left or right, it remains in contact. So you can spin it quickly, slowly, any angle you want, around 360, multiple times, whatever. Just a way of eliminating the problem with all these heavy wires twisting around by hand, left and right, for hundreds of hours of operation. These are high voltage wires. You can tell by the size of the wire itself. This is where it was cut off. The actual wire diameter is here itself, the copper in each one. There's a lot of voltage there. More than, say, a welding machine. It's about 300, 350 amps. It's a lot of amperage. That'll power just about anything, kind of amperage. So here I am at the Kid Cave, just having a good time, enjoying myself, doing a lot of interesting projects, a lot of interesting restorations, and looking forward to getting the Kid back into town. I miss it. I miss being on the ship. That was my Kid Cave afloat. It really was. It's something about it just being on the water in the Mississippi, whether it's 30 degrees or 110 degrees, 120 degrees. It's a lot hotter, colder than this. But I miss it a lot, just being out there.